Hello, welcome back. Management information systems users must be able to productively utilize their systems regardless of where users and systems happen to be located. As discussed in previous videos, this is achieved through a combination of distributed information systems and distributed infrastructures built on top of computer networks. In this section, we will discuss distributed infrastructures and specifically what is known as the cloud. The concept of cloud is generally associated with distributing computing and storage capacity, that is, the infrastructure, over various locations accessible through the Internet. Thus, the load required by a given management information system at any given time could be dynamically and transparently allocated to the part of the distributed infrastructure best suited to serve it. In our business analogy, it would correspond to a company having flexible access to factory capacity and warehousing space in various locations throughout the world, linked by transport routes such as roads. That could theoretically allow that company to decide at each point in time where to best carry out the production activity it requires. As we shall discuss, this general idea can be implemented in various manners and in different degrees. A first obvious distinction would be between private clouds, in which all these resources are owned and used by the same company, and public clouds, in which a company owns and operates this distributed infrastructure and sells to other companies various services based on it. The equivalent of private clouds in our business analogy would be a company that owns a number of factories and warehouses in different places. Public clouds would correspond to a company that owns these factories and warehouses and sells to other companies various services based on it. In a traditional computing infrastructure approach, a company could have in its premises one or several computer centers in which the main server computers and the corresponding storage capacity would be located. Users would access them through the company's private network. It is worth highlighting that even this traditional infrastructure could support the various types of distributed information systems discussed previously, such as multi-tier client-server models. A company could decide to move its computer centers off-premises. To achieve some redundancy to protect itself in case of a major failure in one of these computer centers, it may even, for example, design one of them to act as a backup or alternative to another more critical center, if the latter gets somehow disrupted. Access would normally still be through the company's internal network. Most likely, ad hoc fiber optic links would be rented from telecom companies to hook up these data centers to the existing private company network. Some access through the internet, at least as a backup, could also be contemplated. Now, this approach could have its advantages, but it would not really be considered a cloud. Information systems would still always run on the same computing and storage resources, except in very exceptional circumstances such as a computer center breakdown. This approach would lack the critical feature of allowing dynamic allocation of computer resources. Many of the advantages associated with cloud computing stem precisely from this ability to decide at any given time which computing resources to use to serve the needs of each management information system and its users. That is, dynamic allocation of resources.
Okay, yes, but each information system requires a different type of computing resource, different types of computers, running, for example, different operating systems. To be able to use them interchangeably, would I have to always use exactly the same computer types for all my systems? What about public clouds?
Good question. Here is where a critical ingredient of cloud computing comes in: virtualization. Virtualization, as its name suggests, is a set of tools and techniques that support the simulation of virtual computers based on the real physical computers. As an example, we can simulate several Windows-based computers on a single Linux-based server. We could also simulate on a single real physical server 3 Windows-based computers of various capacities running different versions of Windows and a 4th Linux-based computer. The same goes for storage, that is, this capacity. We can simulate virtual disks on real storage devices and present them to the users as if they were attached to their virtual computers. The application software, that is, the management information systems, such as an accounting package, running on a virtual system would not realize it is virtual and would not notice that the actual hardware it is ultimately running on is different. It is this virtualization trick, along with appropriate management software and tools, which allows dynamic allocation of resources. Thus, going back to our private cloud example, a company would set up various computer centers accessible to its users through its private network and/or internet. It would normally try to standardize the types of computers it uses for simplicity and economy. And on top of these real computers and real storage devices, it would then simulate the types of virtual computers and associated storage capacity required by its information systems. Since this simulation is software-based, appropriate management software can dynamically allocate the physical resources on which each virtual resource would run. Thus, information systems and the users are decoupled from the physical machines on which they run. Now, we could properly say that this company has a private cloud. It could reap a number of benefits, such as load balancing. Different information systems might require more capacity at different times. This approach allows this uneven load to be balanced across resources. This is particularly applicable in global companies operating in various time zones. Redundancy. If the cloud has spare capacity, or if the most critical systems can be identified, if some of the computing resources are not available, the information system would automatically be moved to the resources that are still operating. And standardization of the hardware. Some of these advantages, however, could be exploited much further if the use of this flexible cloud infrastructure were shared by a number of companies. Thus, in the next video, we will discuss public clouds. Thank you. See you there.